Okay, so for anyone here doing the worksheet, the homework worksheet, the assignment worksheet for today, January, let me adjust this here because on my original, there we go, 19th, or on the 20th, and didn't get the kind of the live instruction. This is kind of the gist. We're interpreting box and whisker plots. Okay, so the first order of business is we kind of have to look at what some of these details here on a box and whisker plot mean. Okay, so let's just look at this plot right here. Okay, so what a box and whisker plot does is it breaks our data up into quarters. Okay, so a fourth of our data is here. A fourth of our data here, a fourth here, a fourth here. Okay, so average monthly high temperatures, well, there's 3 months here, 3 months here, 3 months here, right? So it chunks our data just into equally sized blocks. How big those blocks are tells us how spaced out or how chunked together those blocks of data are. It doesn't necessarily tell us how many of this or how many of that. It's just how close our data is grouped so that we can see trends and we can see consistencies or inconsistencies. Okay, so we'll probably, foreshadowing, we'll probably answer some of those questions and see some of those details as we go through. But, okay, step one here is really just to look at this box and whisker plot and pull the information out, because what we've done already is take the information from our table and make a box plot out of it, or a box and whisker plot out of it. But it's helpful to be able to go the other direction. Okay, so what do we got here? Well, we have a box and whisker plot with a minimum of 26 and a maximum of 80, right? Because our minimum, this line down here, and our maximum, that line up there, that's data that we're used to seeing, and we can see that it's right here in our table. So our minimum is 26, our maximum is 80. Where is our median on a box and whisker plot? Well, it's the vertical line here that's inside of the box. And on this one, it's at 57. Okay. Our lower quartile, okay, or as we've been kind of calling it, our first quartile, or Q1, is here at 35. And our upper quartile, or Q3, is up here at 73. Okay, so you'll see some different terms used and vocabulary used for different parts of this, but the terminology tends to be pretty interchangeable and pretty obvious what we mean, and we try to be as flexible as we can. Now, this is a term that I'm pretty sure I've used before, but maybe not defined. All right? The interquartile range is just this. Okay? That it's the range of that box that is really the middle of our data. Half of our data, big block right in the middle, is between these values, between 35 and 73. So when we ask for the interquartile range, what we're looking for is how wide is that box. Okay? So when we talk about range, normally we're talking about the range of our whole set of data. So 80 minus 26 would give us a range of 54. In this case, 54 degrees. For interquartile range, we just want to know how big is the middle of our data. Okay, so here we take 73, we subtract 35, and we get 38. So that's our interquartile range. Okay, so looking at the box plot, taking the information off and putting it into the table, kind of the opposite of what we've been doing, is actually pretty straightforward. Okay, so what's next? Well, For the next set of questions here, the following box and whisker plot shows class data from a math test. Answer questions 2 through 6 based on the graph. Okay, so here we're starting to look at a box and whisker plot, at this graph, and figure out what it's saying. Okay, well, what was the high score on this test? Well, we're looking at our data. We want the maximum. Okay, so the highest score on this test was 102. And notice these are percents. So there must have been some bonus points on this test, so somebody scored 102%. Okay. Well, what percent of the class scored above 72%? Okay, or scored above 72. Well, here's 72. And what do we know about a box and whisker plot? Well, this left whisker between our minimum and our first quartile is, now let's do this as, this is 25%. The bottom half of the box between the first quartile and our median is 25%. Same with this half of our interquartile range here, 25%. And this top little whisker, this is 25%. So what percent of the class scored above a 72? Well, 25% plus 25% plus 25%. That's 75%. Scored a C, or basically a C or better. All right. What's the median score on the test? Right? If we put all of the scores in order, what score is going to be in the middle of that list? Well, right here, remember that line in the middle of the box is our median. So we can say 88% is the median score on that test. Not bad. What percent of the class scored between 88 and 96%? By definition, half of our data is to the right of our median and half of our data is to the left. So if 88, oh, sorry, I got getting ahead of myself there. Oops. Okay, so if 88 is our median, 96, I thought they were saying 102. 196 is our third quartile, it's our upper quartile. Well, what percent of the class? This box just represents 25%. If what they're asking for are the limits of that box, well, okay, 25%. This is asking us to make a judgment. Do you think this test was too hard for the students? Explain. Okay. I'm going to say, no, it's not too hard. Because 75% of the class here, right, 25%, 25%, 25%, passed this test with a C or better. Now, we don't know how many people were down here around the 60% passing mark, but some number of them must have been. So I would say a high percentage of the class passed the test, certainly with a C or better. 3/4 of them did. Half of them passed with what's just below an A. So nearly half of the class got A's on the test. So I would say, no, this test was not too hard. Okay, so we can look at the graph, we can look at the percentages, look at the numbers, and make some kind of a judgment on it. Okay, so let's look at a different graph here. So for these questions, we're going to look at the box and whisker plot, and this is a box and whisker plot that shows the average minutes per night spent on homework for some group of students. Right? Maybe they polled a whole high school, or they just talked to a random handful of students from a class. Okay, so let's see what the graph tells us without even going into the table. Okay, so what percent of the students spent more than 60 minutes on homework per night? Okay, so this is average minutes, so let's find 60. Okay, where on this graph does it show the students that spent more than 60 minutes? Well, everything from 60 up to our maximum. And if we remember, that stretch of our graph here is 1/4 of our data. This stretch here is 1/4 of our data. Same with here. Same with here. Okay, this breaks our data up into 4 equal chunks, at least as far as the number of data points. So what percent of the students spent more than 60 minutes on homework? Well, more than 60 minutes is just this last quartile. And we know that's 1/4, or what percent? 1/4 is 25%. Okay. What is the range of time the middle 50% of students spent on homework per night? That's the interquartile range. So it's just our upper quartile minus our lower quartile, or Q3 minus Q2, 60 minus 20, 40 minutes. Okay, what's the range? There's a difference of 40 minutes between the upper boundary of our middle and the lower boundary of our middle. Okay. Oh, let's keep that. So what percent of the students spent less than 20 minutes per night on homework? What percent spent less than? Well, here's 20. Between 20 and 0 is 25%. 25% of the students that answered this survey, this poll, spent less than 20 minutes. So next question, number 10. Are there students that do no homework? Explain. Yes, because we have a data point down here at our minimum that says at least one student does 0 homework. There might be 1, there might be 2, there might be 3, who knows how many, but that's the minimum number that we got on our survey. So there's at least one person that does no homework ever, which is kind of terrible. But, all right. So what is the range of the data? Well, our maximum is 190. And as we said, someone down here does 0 homework. So our biggest value minus our smallest value is 190. So we've got a range of things. Some people are doing over 2.5 hours, over 3 hours of homework a night. Someone out there, and then someone's doing nothing. So true or false questions. Since the 4th quartile, let's get this picture back in. Since the 4th quartile is much longer than the other 3 quartiles, there were more students who spent between 60 and 90 minutes, this distance, per night on homework than students that spent 40 to 60 minutes. Okay, so we're comparing the number of students here versus the number of students here. Here's the thing. There's the same number of students in this block as there are in this block. These students are all just focused and are on the same kind of numbers, where these over here are very, very spread out. Okay? So this statement is, in fact, false. Okay? So last one, real quick before I get under my 15-minute time limit. This box and whisker plot does not tell you the total number of students. True. Box and whisker plots don't tell you the total number of data points, just how your data points are distributed. Okay? So use that information and see how you do on the assignment page. If you have any questions, feel free to ask. Good luck.